So good morning everyone and welcome to this lecture. This is lecture number 1 and we are starting with the new topic, center of mass. So this is the beginning of a new topic, center of mass. In the previous class we had discussed the topic of work, power and energy, and we have done everything related to the topic. Now we venture into this one. Anyone has any idea what is center of mass? Anyone has any idea what is center of mass that you would like to say? Have you heard the term center of mass before? The answer is either a yes or a no. Yes, Peter. Have you heard about this term center of mass? Have you heard about this term center of mass? Okay, think and tell me whether you have heard this term or not. Take your time. Tell me whether you know this term. Have you heard this term or not?
Don't know, sir.
Okay, don't know. Okay, center of mass. So this is the first time we are hearing a term, center of mass. So the center of mass. Yes, anyone want to say anything? No. Um Up till now, what we have been doing is we are treating any body as a point object. We were not worried about its size or shape. I mean, if it is a bus, we were taking it as a point. If it is a man, we were taking it as a point. Car, elephant, aeroplane, anything, we were taking it as a point. Up till now, what we were dealing with was translational motion of the body. The body was moving in translational motion. Now, we are now going to get into a condition where we will not have just one body to deal with. We might have more than one bodies to deal with. Also, that body may not be just a point object. It may have a physical dimension, it may have a size, it may have a shape, it may be a rod, it may be a cylinder, it may be a sphere. So we are going to deal with different shapes of bodies. We are going to deal with a collection of bodies, or I should say a collection of particles. Now, whenever I deal with such a body or a system or a collection of particles, there is one point, there is one point on that system whose motion characterizes the entire translational motion of a body. What do I mean by this? If I have this pen, if I have this pen and if I throw it like this, so if you see it's going like this, it's a very complicated motion. If you think about any point on this body, if it is moving like this, the pen is moving and it is also rotating. Now if you look at the motion of any point of the pen, the motion of any point of the pen is going to be a very complicated one. Will be very, if you try to imagine the motion of this point of the body, the motion of this point of the body is, you can see, very complicated. It's not very easy to understand the motion of this point of the body, but there is still one point whose motion is very simple. That one point is just going up and just coming down. Do you understand what I'm saying? So even if there is a very complicated motion of a body, Even though the motion of the body is very complicated, we can identify a point whose motion is very simple. In fact, whose motion tells us the how the body as a whole system is moving. That point is known as the center of mass. So what is the center of mass of a body or a system of particles? The center of mass of a body, physical system, or a system of particles is a point COM of a body or a system is a point whose motion describes the translational motion, the translational motion of the body or the system as a whole unit. Are you able to understand what I have written here? Are you able to understand what I have written here? Now, how do I make you understand this? For example, if I take this random body and this random body is made up of a large number of particles, let us say M1, M2, M3, M4, M5, M6, and so on. Now, I can apply different forces on these bodies. There could be an F1 force here, there could be an F2 force on this body like this, there could be an F3 force. Sorry, let me just name them accordingly. There could be an F1 force like this, there could be an F2 force like this on this body, there could be an F3 force like this on this body, there could be an F4 or F5 force like on this body. Now this body is going to have a very, very complicated motion. Do we understand this? This body is going to have a very, very complicated motion. This complicated motion of this body is going to be a combination of a translational motion and rotational motion. There is one point on this body. If you study the motion of that point, that will give us how this entire body is moving as a whole unit, how this entire body is moving as one body. That point is known as the center of the mass of the body. Do we understand this? So, now what is special about that center of mass? Now we'll try to draw it in the diagram itself. I can find a point on the body, this point, COM, and I can apply a force like this, F net. Now, this F net, that is the force applied on this body, will be the summation of Fi. Do we understand the meaning of summation of Fi? Okay. Now, and we can assume that the total mass of this body, M, which is the summation of Mi, is kept at this point. So this point can be treated as the point where the entire mass of the body is kept and all the forces acting on the body is acting on that point. So that is the next thing that we have to remember about center of mass. Center of mass, remember, is a fictitious point. You understand the meaning of fictitious point? Do you understand the meaning of fictitious point? It's an imaginary point. Such a point does not exist. We have just made this point so that we are able to understand the motion of a body in a better way. It's a fictitious or an imaginary point. It's a fictitious or an imaginary point. Such a point does not exist in reality. It's just a fictitious point. It's just something that we created from our imagination. Just because we want to make a complicated thing simple, we have made this point. Entire mass of the body, entire mass of the body can be thought of as kept at the center of mass. So we can imagine that this entire mass of the body, this is a rod. This rod has mass in different places. But just for simplification, I can imagine that the entire mass of the rod is at one point. And that point is center of mass. All forces acting on the body or on the system are acting at the center of mass. All the forces acting on the body are acting or applied at the center of mass. Motion of center of mass represents the translational motion of the body. Motion of the center of mass represents the translational motion of the body. Center of mass, remember it's an imaginary point. Center of mass can lie outside or it can also lie inside the body. Center of mass is a fictitious point. It may lie outside or it may lie inside the body. Has everyone understood the main points about this center of mass? Center of mass is an imaginary point. It does not exist. It can lie anywhere. It is just a point from our imagination. And we can imagine the entire mass of the body is kept at that point. All the forces acting on the body is acting on that point, and therefore the motion of center of mass will give us the translational motion of the entire body. I'll give you 2 minutes to note this down. Note it down and let me know. Can we move ahead?
Sir.
And remember these points about the center of mass. We have noted some. Um, I will give you one or two more important points. You can note them down, then we will move ahead. Important point number one. Apart from whatever we have already written, these are important points. The center of mass And first we will also find out the center of mass, but let us write this important point. The center of mass of a body is independent of the coordinate system. No matter what your coordinate system is, the center of mass will not depend on your coordinate system. The position of center of mass depends on the size, shape, geometry, and the distribution of mass. The distribution of mass changes if you have more mass here and less mass here. The center of mass will change. If you have more mass here and less mass here, the center of mass would be different. Do we understand this? Yes or no? Do we understand this? Yes or no?
Yes, sir.
Okay. If the body is symmetrical, and I hope you understand what do you mean by a symmetrical body. If a body is symmetrical, then the center of mass will lie at its geometrical center. Do we understand this? This body is symmetrical. This body is symmetrical. So where will the center of mass lie for this body? It will lie at the center. Do we understand this? This body is symmetrical, equal mass everywhere. Where will the center of mass lie? At the center. This body, this rectangle is symmetrical. Where will the center of mass lie? At the center. Do we understand this? We'll give you 2 minutes to note it down. Apart from this, you should remember other point. Point number 4. Center of mass may lie outside or inside the body. I've already given you this point. Yes or no? So it's not necessary that it may lie only inside. It may lie outside the body as well. Note it down and let me know once you are done. Then we move on to the next heading. Center of mass for a system of end point masses or end particles. So we have a large 2, 3, 5, 10 number of particles, and we are supposed to find out the center of mass of that system of particles. How will you find out the center of mass for a system of particles? Suppose you have a system of particles where you have different masses m1, m2, m3, m4, m5, and so on. You obviously will need a coordinate system to locate the center of mass. So what do? You locate the points m1, m2, m3, and so on with their position vectors. Do you see their position vectors? R1, R2, Rn. Do you see this? Yes or no? Now, how do I get the position of the center of mass? Well, the formula is very simple. You can just apply this formula. M1 R1 vector plus M2 R2 vector plus Mn Rn vector divided by M1 plus M2 plus M3 up till Mrn. Do we understand this formula? It's a very simple formula. A very simple formula that you can remember. Yes or no? No, yes. Do you understand this? Or if you want to write it in summation form, this is how you can write it in the summation form. Summation of I from 1 to n divided by summation of mi. Everyone understands this? Yes or no? No, yes. Huh?
Sir.
Okay. Now this is how you can find out. This is how you can find out the position vector of the center of mass. But sometimes you may not want to find out the position vector. You may only want to find out the x coordinate of center of mass. the y coordinate of center of mass and the z coordinate of center of mass. If you just want to find out the x, y or z coordinate, how will you find it out? How will you find out the x, y or the z coordinate of center of mass? Anyone? How will you find the x coordinate or the y coordinate or the z coordinate of center of mass? The x coordinate of center of mass you can find out by m1 x1 plus m2 x2 and keep on adding it till mn xn, and you divide it by the total mass m1 plus m2 up till mn. How will you find out the y position of center of mass? Yes, anyone?
M1 Y1 plus M2 Y2.
m1 y1 plus m2 y2 up till mn yn divided by m1 plus m2 up till mn. How will you find out the z coordinate of center of mass? How will you find out the z coordinate of center of mass?
Z1 Y1 plus M2 Z2.
m1 z1 plus m2 z2 up till mn zn divided by m1 plus m2 up till mn. So basically you can write this like this: x coordinate of center of mass is nothing but summation of mi xi divided by summation of mi. The y position of center of mass is nothing but summation of mi yi divided by summation of mi. The z position of the center of mass is nothing but summation of mi zi divided by summation of mi. I'll give you 2 minutes to note this down. I hope there is no doubt in this one. So, since everyone is finished, let us move ahead. This is center of mass for a system of n particles. Um, in some cases, we will come across two particle system, because this two particle system comes at a lot of times. So you can just see how can you find out in different ways the center of mass of a particle consisting of two particles. How will you find out the center of mass of a particle which consists for a system which consists of two particles? It is really simple. You just have to put the formula. R vector would be equal to m1 r1 vector plus m2 r2 vector divided by m1 plus m2. Yes or no? No, yes. Huh? Yes or no? No, yes. You just have to apply it for two uh, particles and you will get your answer. Similarly, if you want to find out the x coordinate of the center of mass of these two particles, you can just find it out. X coordinate will be m1 x1 plus m2 x2 divided by m1 plus m2. Yes or no? If you have to find out the y coordinate, you can similarly find out the y coordinate. It is quite simple to see. Do we understand this? Yes or no? You can easily find out the x, y, and z coordinate of the center of mass, but in most of the cases, whenever you are dealing with the center of mass of two particles, the two particles might be put like this. And this is the most important diagram that we will come across. The particles would be put like this, yes or no? M1 and M2 separated by a distance of r. So that is how the question would be. M1 and M2, they are separated by a distance of r, and the center of mass would lie somewhere in between these two particles. Do we understand this? Yes or no? Now, if this if both of these particles M1 and N2 are of equal mass, then where will the center of mass lie? You don't require physics to understand this. This is common sense. If both M1 and M2 are of equal mass, where will the center of mass lie? No one understands this?
Point.
It will lie at the it will
Middle.
lie at the
Middle.
midpoint. Now, if M2 is heavier, M1 is lighter, will it lie at the midpoint or where will it lie? It will lie towards the M2 side or it will lie towards the M1 side? M2 is heavier, M1 is lighter.
Two side.
It will lie on the M2 side. So basically, if I call the distance as R1 and R2, it is very easy to see that R1 by R2, the ratio of R1 by R2 will be in the inverse ratio M2 by M1. Do we understand this? Or you can write it in this form. Is it making sense or is it going above our head saying bye bye sir हो गया निकल जाते हैं अपन अब we had enough of this. Are we able to understand this or this is going above our heads? Are we able to understand this or bye bye? Okay, so basically what we want to write here is this simple equation that M1 into R1 will be equal to M2 into R2. Nothing else, nothing more, nothing less. And we also know that M1 plus M2 will be equal to R. So solving all these equations together, keeping all these things together, we have this revolutionary formula for R1 and R2. What is that revolutionary formula for R1 and R2? I can have R1 equal to M1, not M1, M2 into R divided by M1 plus M2. Do we understand how I got this formula? Or it is going above our head saying bye bye. And we will have R2 equal to M1 into R upon M1 plus M2. Do we understand this or this has gone above our head saying bye bye? Sir, we are going bye bye. I'm going bye bye, sir. So remember these formulae for your two body system. These formulae may come handy at various points in life. I'll give you 2 minutes to note them down. So we have done the theory part. Now comes this question number 1. And the question is pretty simple. Two particles of mass 1 kg and 2 kg are located at x is equal to 0 and x is equal to 3 meter. Find the position of their center of mass. I'll give you 2 minutes to give me the answer. So, how you have to do this? You don't need even a diagram for this. You can just write the formula. X position of the center of mass is m1x1 plus m2x2 divided by m1 plus m2. Here your m1 is 1 kg, your x1 is 0, your m2 is 2 kg, and your x2 is 3. So it will be 3 into 2, which is 6, divided by 1 plus 2, and your answer would be 2. As simple as that. Do we understand this? Everyone got the answer for this? Well done. Then that brings us to the next question. And I hope that I can get the answer for this question quickly. And here is the question coming for you. The position vector of three particles of mass m1, m2 and m3 are this. Find the position vector of their center of mass. I'll give you 2 minutes to give me the answer for this one. So how are we supposed to solve this question? Question number 2. Everyone seems to be lost. I don't know why you are lost. Position of center of mass, position vector of center of mass is nothing but summation of mi ri vector. Here is summation of mi ri vector divided by summation of mi. Is it so difficult to multiply and divide, beta?
No, sir.
Why you are taking so much of time, beta? So difficult to multiply, divide and add? Huh? What is the answer that you are getting? You just have to multiply, divide, multiply, add, and then divide. It is so difficult.
3 I cap plus J cap plus K caps are all, sir.
I don't know, beta, what's happening. I'm really worried about you. The answer that I have is this: half 3i plus j minus k. I don't know what you are doing. I mean, you are taking so much of time to multiply and divide. I don't know what's going to happen in the future. Anyways, this is the answer for this one. Please note it down. I'll give you 2 minutes to note it down. So here comes the next question. The distance between carbon and oxygen atom in a carbon monoxide molecule is 1.1 Armstrong unit. Mass of the carbon atom is 12 AMU and the mass of the oxygen atom is 16 AMU. Calculate the position of center of mass of the carbon monoxide molecule. I'll give you 2 minutes to solve this question. And I hope that you give me the correct answer. Okay, I'll give you a hint to solve this question. You can draw your diagram like this, and then you can find out the location of the center of mass. And I'm going to give you this question as a homework. This is a very simple, straightforward question that will give you a lot of confidence going up. So I'm not going to solve it for you. I'm going to give you this question as homework. It is a very simple question, and I'm sure that you will be able to do it once you get time at home. So I'm leaving this question as an exercise for you. Find out the position of the center of mass, imagine it where it is, and let me know the answer in the next class. This is center of mass lecture number 1, and we are trying to find out the center of mass of a system of particles. We will continue our journey in the next class, that is tomorrow, and move ahead. I hope you have enjoyed this class, everyone. Did you understand what we have done in this class?
Yes,
We
sir.
will go ahead with the same topic in the next class. Meanwhile, this is a question for your thought. Solve it and come back to me. Take care. God bless all of you. Bye bye.
Thanks, sir. Take care.
Bye, beta. Take care.